Hey guys, today we're going to be talking about Chapter 2, The Chemistry of Life, Section 1, The Nature of Matter. So these are some things that you probably remember most of this from middle school, but we'll just go over it very quickly. So first of all, the basic unit of matter is the atom. So we'll be looking at the structure of the atom. Here you recognize the center, which is called the nucleus, and then you have the rings that are around it, where the electrons are orbiting around the nucleus. So again, in the nucleus, you have the protons and the neutrons. And the neutrons are neutral, meaning that they have no charge. The protons are the part that does have a positive charge. That's the subatomic particle with positive charge. And the two of those, the neutron and the proton, are relatively large when compared to the electron. So they're together in the nucleus. Then you have the electron, which of course is a negatively charged particle. It's really small compared to the protons and neutrons, and it travels in orbits around the nucleus. Now, atoms are the smallest unit of an element, and elements are represented here in the periodic table. You have things like hydrogen, helium, and gold, and oxygen, and fluorine, and neon, and all of those are unique in the number of in their atoms. So there's over 100 elements, and they're usually represented by one or two letters. Sometimes the letter doesn't seem to match the element. For example, so helium, He, helium, that makes sense. Carbon, C, carbon. But then you may have gold, Au, and that's from the Latin word for gold, and so that's why several of them don't match their name. Isotopes. Well, sometimes atoms may have different numbers of neutrons. For example, in carbon, you always have 6 protons. All carbon has 6 protons, or it wouldn't be carbon. And how do we know that? We get that from the atomic number. So if you go back to the periodic table and you look at carbon, you see that the atomic number indicated at the top there is a 6. And they're organized according to their atomic numbers, which is telling you how many protons are in each atom. So if we go back to this chart here, you see that all of these carbons have 6 protons. And actually they all have 6 electrons as well, because electrons and protons are typically balanced to make the atom neutral. However, in carbon-12 you have 6 neutrons, in carbon-13 you have 7 neutrons, and in carbon-14 you have 8 neutrons in each atom, in each nucleus. And so those are known as isotopes. They're variations of carbon. They all have 6 protons, but they have different numbers of neutrons. And in this case, carbon-12 and carbon-13 are non-radioactive, but carbon-14 is what we call a radioactive element, meaning that its nuclei are unstable and are constantly breaking down and turning into something else, which is a pretty cool study, actually. Now, we also have a term called atomic mass. Atomic mass is the number of protons and neutrons in the nucleus. So when you look at a periodic table, you're actually looking at 2 numbers. You're going to see the atomic number on top of the letter, like 6 in carbon. And then most often there's another number underneath the C, and that's called the atomic mass. So in this case, it's 6 plus 6, 6 protons plus 6 neutrons equals 12. So the atomic mass is 12. And that number is important because that's how you figure out the number of neutrons when you are drawing an atom, for example. Now, atoms combine to make compounds. And when they combine chemically. So a chemical compound is a substance that's formed by the chemical bonding or the chemical combination of 2 or more elements. So, for example, 1 nitrogen and 2 oxygen makes nitrite. 1 nitrogen and 3 oxygen makes nitrate. 1 sulfur and 3 oxygen makes sulfite. And 1 sulfur and 4 oxygen makes sulfate. So how do those atoms stick to each other? Well, there's 2 kinds of chemical bonding that we're going to look at, ionic and covalent. And you may have talked about this before. Let's start with covalent. Covalent is when electrons are shared by atoms. They share electrons together, and that holds them close, and they form a new compound. And when atoms bind together, they form a molecule. So now you have a molecule of sulfite, a molecule of sulfate, a molecule of water. Ionic bonds are when atoms, instead of sharing electrons, they actually give them away or take them from another atom. So if they gain electrons, then they are going to actually have a negative charge. If they lose electrons, then they're going to become positively charged. And this forms when one or more electrons are transferred, not shared. And it forms what we call ions. That's why it's called ionic bond. It's because an ion forms, which is a positively or negatively charged atom. Because they're giving away electrons or they're gaining electrons, it throws off the charge and they become positive or negative, whereas normally they would just stay neutral. So here you have two atoms sharing electrons, two carbons, and they're sharing this electron in the middle. They each are sharing one. And what's interesting about that is now that they're sharing, well, in this case, they're only sharing one, so it's depicted as a single, what we call a carbon bond. But sometimes atoms will share 4 electrons, that's what we call a double bond, and sometimes they'll share 6 electrons, which makes a triple bond. And that just depends on the type of element we're talking about. Your book also mentions a type of force called van der Waals force, which is it's not ionic, it's not covalent, but it is an interesting force that occurs, creating a stickiness to substances. So in this case of the gecko, the underside of his foot is covered with millions of tiny hair-like projections, and then each projection is actually covered in even finer fibers, which creates a lot of surface area for sticking. And this allows the gecko to scurry up the wall and across the ceiling. And these little forces that form and hold the wall or glass to the foot of the gecko are known as van der Waals forces. And that's it for sections 2-1.